I had someone message me about this first tipper or typer with a question on it. And so these are meant to be fairly thought provoking. So it's okay if you don't get them all. But I do want to go over um, at least this example, maybe one other example here. So all you have to do with this, by the way, was just to write down what you thought the summation of the forces on charge B would be. So you've got three charged particles, A, B, and C are fixed in place. Charge C is twice as far from B as charge A. All charges have the same magnitude. So construct a bar chart or just tell me the net force on B due to the charges A and C. So use positive values for net forces directed to the right and negative forces or values for forces directed to the left. For forces 0, state that explicitly. So this example gives us +3. The way that they do that is if you think about this, this would have a certain amount of force between these two. It would be a repulsive force, so this would be directed to the right. Okay. B and C also, because they have the same charge, have a repulsive force. So the force on B from C would be to the left. How would the magnitudes of those compare? Well, if I go back and I think about Coulomb's law, which is that electric force is equal to the constant times Q1 times Q2 and all that divided by the distance, so I'll do R squared, then what I can see from this overall general formula is that double the distance would cause the force to be a quarter as much. So what I'm going to do is I'm going to think of this as causing 1 unit of force between them, and that would act to the left. So not like that. So in my mind then, what this is on B here, I've got 1 unit of force to the left because these repel. Now, if I look at that, A and B should actually have a significantly longer amount of force to the right. Why? Because they're twice as close. And so therefore it should have 4 times the amount of force to the right. So if I think of this as 1 unit of force to the left, and the force between A and B is 4 units of force to the right, that means I have a net value of +3 or 3 units of force to the right. You do the same thing with each of these examples. So for example, down here, A and B have opposite charges, so the force on B would be to the left. B and C have opposite charges, so the force on B would be to the right. But the magnitude of this force is only going to be 1/4 the amount as the magnitude of this force. And that should do it.